Welcome to the Explainer, everyone. Let's just jump right in, because today we are looking at something completely fascinating in the world of software development. Look, as developers, we are all leaning heavier and heavier on AI coding agents, but actually keeping them focused and disciplined, that's a massive challenge. Well, enter Killhouse. This is an orchestration hub designed specifically to bring military-grade discipline to AI coding agents like Claude Code and Codex. I am so excited to break this architecture down with you.
Listen to this tagline pulled straight from their repository. A rigorous, unforgiving AI pipeline where code is planned, tested, and audited without mercy. It sets an incredibly gritty, high-stakes tone right out of the gate. We are not talking about a casual pair programming buddy here. This is an environment where your code literally must survive a strict, punishing gauntlet just to see the light of day.
All right, so here's the roadmap for how we're going to unpack this dense framework. We'll start with solving AI context bloat, move into how delegated orchestration actually works, walk through that intense multi-stage gauntlet, get you set up with a quick start for Claude and Codex, and finish up with their strict operating principles.
So part 1, solving AI context bloat and stopping that insane token burn.
Before we can appreciate the solution, we've got to diagnose the core frustration here, which is skill hell and context bloat. When you shove these massive, complex prompts and endless instructions right into a main agent session, you fundamentally break down the AI's ability to reason effectively. It's just overwhelming for the model. Not to mention, you're burning through an excessive amount of tokens just trying to keep all that context alive in the chat window.
So the crucial question becomes, how do we actually stop this? How do we stop the excessive token burn and keep the AI's reasoning from degrading the second a project gets complicated? We need a real structural solution here, because the traditional monolithic prompt approach simply does not scale for enterprise-level software.
That brings us to Section 2, Delegated Orchestration Explained. Killhouse completely flips the script to solve this. The old way of monolithic prompt engineering relies on loading massive prompts right into your main chat session, which, as we established, burns tokens and scrambles the AI's focus. But Killhouse uses delegated orchestration. This completely separates the triggers from the heavy payloads. Instead of one massive prompt, you're just using lightweight pointers in your main chat, which then quietly go and spawn independent, heavy subagents behind the scenes.
To put it simply, your skills act as ultra-lightweight pointers. They live in a tiny folder and cost almost nothing in your main chat's context window. But the moment they're triggered, they activate loops. And these loops are the heavy, multi-agent markdown instructions that actually handle the rigorous software development lifecycle tasks. So you keep your main chat absolutely pristine and cheap, while the real heavy lifting gets delegated. Okay, moving on to Section 3, the multi-stage gauntlet. And trust me, it is unforgiving.
If you are building a major feature, it cannot escape this 8-stage pipeline. Let's walk through the first 4 stages. First up is triage, which determines if a task is just a trivial fix or a major feature. Then comes discovery, which synthesizes your product requirements document. Fun fact here, the brilliant domain modeling skills in this specific stage are credited straight to developer Matt Pocock. Next is the spec audit, and finally, planing, which generates traceability matrices. Notice something crazy here? We are 4 stages deep, and the AI hasn't written a single line of actual feature code yet. It is all about rock-solid preparation.
Now, I really want to spotlight Stage 3 for a second, the spec audit. During this phase, Killhouse triggers a massive 9-agent audit loop. 9 separate subagents compute arithmetic, double-check your assumptions, and enforce narrative flow. They will literally interrogate the specifications until that product requirements document converges perfectly. It is absolutely merciless.
All right, let's look at the final 4 execution stages. Stage 5 uses a wild submodule called the Digital Red Queen, and its job is to actually evolve the execution prompt before any coding even begins. Stage 6 is the execution phase, driven entirely by test-driven development. Stage 7 hits you with a rigorous code review, and Stage 8 is a final architecture review to eliminate any shallow modules or leaky boundaries. The most crucial point in that execution phase is Stage 7, the Code Review Tribunal. Your code doesn't just pass one generic AI. It gets routed to highly specific specialists. You've got a language specialist, a security specialist, a test specialist, a docs specialist, a simplification reviewer affectionately called the ponytail, and finally an architect to synthesize it all. Every single one of these agents must converge on a pass verdict for your code to survive. No exceptions.
So, Section 4, Claude and Codex Quick Start. How do we actually get this running in your own workspace today? while Killhouse ships plugin manifests for both Claude Code and Codex. If you're using Claude Code, it's ridiculously easy. You can actually just be lazy and ask your agent, install Killhouse from GitHub, and you can even add with Red Queen to include that prompt evolution engine we just talked about. For Codex users, you simply add the plugin via the marketplace using the Codex plugin command.
Once it's installed and you fire up a fresh session, this is all it takes. You type /askka followed by, say, I want to build a new feature. That one simple trigger command kicks off the entire multi-stage pipeline, routing your request cleanly right through that minimal context skill we discussed earlier.
Finally, let's wrap up with Section 5, their strict operating principles. You can't keep a multi-agent house this complex in perfect order without some absolute rules. Killhouse operates on 4 uncompromising principles. First, a single source of truth. You never duplicate reference material. Second, no no-ops. Every single instruction must explicitly alter agent behavior. Third, strict leading words. You use dense, predictable vocabulary, like always saying vertical slice, to perfectly steer the agent's reasoning traces. And fourth, falsifiable gates.
I really have to emphasize this last principle because it perfectly encapsulates the entire framework. A gate that cannot be proven to fail at baseline is documentation, not a gate. Think about that. If a test or a check always passes, it's useless. It's just text on a screen. A real gate must be able to fail, and fail hard. That specific philosophy proves exactly how rigorous and unforgiving the Killhouse environment truly is.
And that brings us to the end of our explainer. We've seen how Killhouse destroys context bloat through delegated orchestration, and we've walked its punishing 8-stage gauntlet together. So I'll leave you with this question. Is your current AI development pipeline rigorous enough to survive the Killhouse? It completely changes how we need to think about AI software engineering. Thank you so much for joining me to explore this incredible tool.